Hello and welcome to the AI show brought to you by Lenovo. I'm your host, Emily Barrett, and I'm thrilled to be your guide into the fascinating world of artificial intelligence. In each episode, we'll dive deep into the AI universe, exploring the latest innovations, the people behind them, and how these technologies are shaping our future. On this episode, we'll be joined by Theo, who is the co-founder of CloudNC, who I'll be discussing manufacturing and AI with. So let's begin as we take you on our journey through the world of AI. So, hi Theo, thanks so much for joining us today. Do you want to just start by giving a little bit of an introduction to yourself?
Sure. So my background's manufacturing, mechanical and robotics engineering, but my career really started when I was 15, building and selling high-performance gaming computers on eBay from parts. So I was a Lenovo competitor way back in the day, a very, very small one. Yeah, that was my first business. And but CloudNC is really, is my big business. It's my life's work. And what we do is make it very easy to manufacture extremely complicated metal components, very precise ones like this, which comes out of a hydrogen compressor. It's made out of titanium. It's pretty cool.
It's pretty cool, yeah. In the industry you're looking at, how would you say AI is changing what you can achieve? So I guess the easiest way to do this might be to describe like the pre-AI world or pre-CloudNC world. As to how someone might typically go about manufacturing something like this.
Yeah, so the pre-AI and pre-CloudNC world is I've got to sit in front of a computer for maybe 3 weeks telling a machine how to make this in a highly optimized way. I have to figure out every element of how it's going to be made, what tools are going to cut, where. Oh, I should have mentioned, this started its life as a solid block of titanium, and we cut away in order to get to the final shape. About $400 billion worth of things are made in this way every single year. Like your iPhone, your Mac chassis, the machines that made this chair, almost everything starts its life in a CNC metal cutting machine. And yeah, I've got to tell that machine everything about how it makes the parts. It would be like writing a Word document and then having to spend longer telling the printer how to print the letters by hand than you spent writing the document itself. That's kind of how our industry works today. And I want to live in a world where I can just get this made in a single click of a button, like a 3D printer. A 3D printer can't make this.
That was going to be my next question. Can't you just 3D print that?
Absolutely not, unfortunately. I wish it was that easy.
Yeah, and I think it's really interesting what you've just described there, because I think a lot of people think that there's, the design process for parts like that obviously takes a little bit of time as well. And then there is this view in people's minds that you can just click go and off a machine goes and it will go and chop up this block of titanium to create this.
But it sounds simple, doesn't it? It sounds like how it should be. I used to think it was like that as well, and I was very surprised when I found out that it was not that way at all. I asked someone in my university workshop to make some components for me for a racing submarine, and they said, oh yeah, that'll be 12 weeks. 12 weeks! Term is 10 weeks. That's useless to me. And I just started digging and digging and digging. Why is it going to take me 10 weeks to get this extremely simple components that I feel like I should be able to make at a single click of a button? And that's when I found that everything about how we make metal parts is intensely manual.
And I guess coming from the world as it is today, we are more and more used to that being able to do things at a click of a button. So CloudNC, your mission is to be able to do this with a click of a button, right? Yes. So how is it that you're doing that? How is it that you have created a world where you can manufacture things like that at the click of a button?
So a very long time, a lot of money, and a lot of very, very clever software engineers working in concert with manufacturers and manufacturing engineers in our own company to work out what is the science of how you cut this out. Before we started, that was really unclear. It's a black art. If you can understand the science of why you would cut faster, slower, deeper, shallower with one tool or another in one pattern or another, then you can codify that science into software. And if you can make that software run incredibly quickly, then you start being able to solve the problem of how should I cut this out. So our journey has been a very long one to come up with a tractable way of solving this problem in a computer. It is not an easy problem to solve in a computer. If you've ever heard of the traveling salesman problem, how can I visit a certain number of cities as quickly as possible? Once you get past 6 cities, it becomes really hard for a computer to work out because you go from hundreds of ways to thousands to millions to billions to trillions very quickly, and you can't test all of those ways. This is like that problem on steroids in 10 dimensions.
So it sounds like you need a fair amount of oomph to be able to do this, or at least you would have traditionally.
Yeah, you need a fair amount of oomph, and you need very highly optimized software. You need algorithms that run hundreds of thousands of times faster than the state of the art, if not millions of times faster, in order to be able to make the problem fit in a computer.
So I guess that leads to my next question a little bit around how AI has enabled you to do what you do, right? So you are using some form of AI within that software. So what are you using AI to do?
So I'll talk about how we solve the problem at a very high level. What we do is we look at every surface of this part and every volume of material that we want to remove, and we come up with hundreds of thousands to millions of ways that we could do it. And then we whittle those ways down to, let's say, 1,000 ways that would work for every area. Okay, now you've got 1,000 ways of making every single surface on the component. That's quite a lot of stuff. Then we run a big optimization to go, all right, if I'm doing this way one way and that one another way, probably I should do those the same way. It's a big optimization that comes up with the best way of doing every piece, bearing in mind what's happening everywhere else, interlayered through that whole process of a pretty wide range of AI techniques. AI is a really big umbrella, and we use quite a lot of the tools in the toolbox in order to do that. And that lets us whittle down to one way of making every area, which is the strategy for making the part. Sounds simple. I wish it was. I wish we'd been, done 6 years ago, but it took 8 years to even be able to release a piece of software that worked.
It does. I think it's one of those problems that sounds like it should just be a very simple.
Yeah. Sounds like it should have been done years ago. Yeah. Well, we had that attitude as well.
Yeah. However, luckily you've now managed to get to a point where you can just go out and do it. So if I have a factory and I'm making parts for somebody, how do I go about installing and integrating your software into that factory?
So right now, if I'm sitting in a factory, I'm going to use what's called computer-aided manufacturing software. I click some buttons, I fill in some parameters, and the software will tell the machine, take this tool and zigzag your way down there. I don't have to write literal XYZ coordinates to do that anymore. That's how we used to do it. Our software plugs into that software that you already have. So you download it, and within 5 minutes, it will understand what tools are in the database, what machines are in the database, what the geometry of the component is. And it's just going to go through and basically press the buttons that you would have pressed, but it's going to do that in 5 minutes rather than a day, and leave you with something that is 80, 90, 100% done. And anything the software can't do, you're sat in the equivalent of a word editor. You can just make the changes yourself in the software that you're comfortable and familiar with. So it's like getting a huge head start. It would be like writing a blog article, starting with a ChatGPT draft rather than starting from scratch every time.
Yeah, and I mean, that makes such a big difference to productivity. And also, I imagine, to what you can then focus skills on, right? Because I imagine that there's a lot of what people do in this job that can be somewhat repetitive. So if you can eliminate that, it can help people feel like they're not just doing repetitive tasks again and again and again and again.
Yeah, I hate doing repetitive tasks, and I don't want anyone else to have to do really boring repetitive tasks. There's a lot of fun that can be had making parts like this, but it's not the really boring stuff that you have to do for every single one.
Yeah, and I think it's really cool that you're looking at ways to eliminate that, but also to keep a human element in terms of what you're doing, with knowing that there are going to be bits that might not be perfect or might need looking at, and that's where you'd use that human expertise to come in and go,
Yeah,
right. look at this bit.
With this technology, I can make 5 to 10 times more things than I could before. I can walk into my factory and literally make 5 components for customers in the time that it would have taken me to not quite do one. And that is huge for our industry, because the biggest bottleneck to innovation in the physical world is waiting for things. You know, if I'm designing, let's take an example. If I'm designing a new camera mounting, something very, very simple, I can design that probably in a day or two, but then I've got to wait 6 to 12 weeks before my part actually arrives. That's really going to slow everything down. If I am at, let's just say, making ventilators during the COVID pandemic, a lot of the parts precision machined, huge lead times to get those things. We should live in a world where you can get that kind of thing in 6 days, not 6 months.
Yeah, and I think what's key to understand here is that a lot of that lead time doesn't come from the actual manufacturer. It comes from the keying up of the machines to be able to do it.
It comes from waiting in a queue for people to program the machines and create the schedules and the quality plans, and then getting it wrong before you get it right, and waiting in a queue behind the other stuff that's all got to be programmed. This industry should just look like 3D printing farms or server farms, where you've just got the same machine sat over and over and over and over again, running different things every single time. The factories of the future look like data centers in my mind. You know, you've just got machines and robots running around, the machines program themselves, the robots move the components around, and then they go out the door to happy customers.
Yeah, I mean, I think there's a long way to go before we get to that point, but this is a massive step in that direction. If people can reduce that time to create new things, it will lower the barrier to innovation.
It will. I think that we've lived in a world where the pace of innovation in the digital has been growing exponentially faster. You know, a decade ago, it used to take 3 months and 50 grand for most people to build a website. Now anyone can do it on Wix in a day. And so innovation just moves faster in the digital world because it's easy. And so we make more things, we innovate faster. The same is going to gradually start happening in the physical world. Things will speed up. We'll see more products coming out more frequently, with more exciting features, with greater customization. You know, most things look the same in the physical world because it's really hard to customize things.
Yeah, and I guess that part of the reason why it's really hard to customize things is exactly what you just talked through. So being able to change things more easily is going to have a big impact on the physical things that we are producing as a society as a whole. And I think that's really cool because a lot of the time in this show we talk a lot about things that change in the digital world. But what's really nice here is to see an actual change in the physical world that's happening, because it makes everything much more tangible in terms of the impact that that AI can have on that physical world as well.
It's a big coming wave is AI meets industry. AI meets industry is very hard because industry is not clean data sets that exist only in digital space and only have to deal with other computers. You've got to deal with the real world, and the real world is extremely messy. It's very unpredictable. You can break physical objects that take ages to fix. If ChatGPT or DALL-E hallucinates, it's not really that much of a big deal. If our software hallucinates, then maybe it plunges a 100,000 pound cutting spindle through the machine because they're not that clever, and it's 3 months to repair it and a lot of money. It is very difficult to do industry meets AI, but it is happening. It is happening, and I think that it will fundamentally change the way that we experience the world.
So what you've just described sounds like a really cool process, but I can't help thinking about, if we're talking about generating more and more things, what the environmental impact is of that, and how we actually might be able to use what you're talking about today to create efficiencies in terms of how we do that manufacturing to have a positive impact on the environment.
Yeah, so our industry, manufacturing, is tremendously inefficient, especially this kind. Machines are only running about 20% of the time that they could be. That's a lot of wasted energy in what it took to put the machines together in the first place. We scrap huge numbers of components, and when you scrap something like this, you waste all of the energy that went into making the metal billet, the actual cutting itself, and then you've got to go make more of them, and the machines could go a lot faster than they theoretically do, and all the time that they're doing that, they're consuming like 20,000 watts each. The scope for energy and carbon savings by making this industry more efficient are pretty mind-boggling, and so the environmental benefits of making this industry more efficient by making it, one click, easy to run the machines all the time, making perfect parts, they are absolutely enormous. A sizable portion of global energy consumption goes into this industry, and that could be an awful lot less than it is. So significant environmental gains. And as for what it means for the world, right now it makes a lot of sense for me to go and get something like this overseas. Really, these should be made closer to the source. The only reason they're not is because labor is extremely expensive and difficult to come by in many Western countries. Take that off the table, it makes sense to make things like this in an onshored manner. And then they have much lower distances to travel. Again, carbon savings, energy savings, environmental savings. This industry could be so much cleaner than it is. And it's not for lack of will, it's just for lack of technology.
That's, I think, a really, really, really important point here, because, as you say, we all need to be thinking about the future and the impact we're having on the planet, and ways in which we can create a cleaner, brighter future for us all. To sound incredibly cliched, but it's true, right? If there are efficiencies that you can make in terms of energy saving, in terms of that impact, it's well worth doing.
I would like to make 1 million machines plus around the world 4 times more energy effective than they are. That's the kind of energy saving that gets me out of bed in the morning.
Rather than have I turned my lights off when I've left the house?
Have I put some solar panels on the roof of my one factory when there's 100,000 out there to impact?
Yeah. This is, we're talking about changing things at a massive scale here.
Exactly. The big wins.
Yeah. Thank you very much, Theo.
Thank you.
It's been great to talk to you. Thank you all very much for joining us for this episode. We hope you've enjoyed it, and we will see you again next time.